So we've got a change in setting here. We're going to do a little bit of a science demo on stage, and we are joined by Lahiri Chalasani from the Children's Science Center. This is located in the Fair Oaks Mall in Fairfax, Virginia, and we're going to do something called the Science on Stage. This is something you guys do at school visits, right?
Yeah, so we take these out to local elementary schools all across Northern Virginia, and we deliver hands-on science in like a demonstration assembly format.
Assembly format, and they're visual. They're really exciting.
Yeah.
And what have you brought for us here today?
So we have something called elephant toothpaste, and I believe Camille is very familiar with this activity, so we wanted to bring it back and do it again.
This was your demo.
This was the demonstration that I did at Miss Virginia and at Miss America.
Okay, so go ahead and take us away, Lahiri.
All right, so I have our giant Erlenmeyer flask right in front of us over here, and it kind of looks like water, but we don't want to assume anything is ever water when doing a science experiment. So what's in here is our hydrogen peroxide, and so it's chemical formula H2O2. Let's see if we can make H2O with our bodies. Can we make like little mouse ears like this? So these are like our hydrogen atoms, and then we're the O, right? So here's our little H2O. So a really easy way to talk about H2O to everyone. So hydrogen peroxide over time actually releases oxygens back into the air, right? And so looking at it, you can't really see that. You can't see oxygen coming out. So we want to trap those bubbles, trap that air into bubbles and see it. So I have a special ingredient. Okay,
Should we get
awesome?
Oh, safety first. That's really important.
Yeah, we should make sure that we're ready.
So we put our lab coats on.
Is there anything?
You might want to roll your sleeves down.
Okay.
It needs to be
And I'll put my hair back for this too.
That's really smart too, yeah. Mine's clipped and yours is short, so that's good.
Short.
Are we missing anything else? I think we have some
we got
safety.
some other things.
Yeah.
Let's put our gloves on.
So when you're doing science on stage demos, or Camille, when you're going in and you're doing demonstrations, not only talking about how science is cool, but safety, because if kids are going to try out science and do some home experiments, or going when they get into school and they're doing experiments at school, safety is the #1 priority.
Of course.
Especially for me with the eyes, because you only get one pair of eyes. So to protect those, I've been in situations when I do these demonstrations where I've actually burnt my skin a little bit with the hydrogen peroxide. But the benefit of your skin is it regenerates so easily. And I actually did burn my skin quickly during my demonstration at Miss America backstage during the live broadcast. But I was lucky I had the personal protective equipment on that I needed. And so it mitigated a lot of the potential risk that I had. And so it's part of what I share with the kids as well. So definitely an important thing.
I'm going to complete button up over here so we can all be ready, right? So we have some gloves
Exactly.
on.
And we have closed-toed shoes on.
Yes.
Yes, we do.
You can't see them, but yes. Also very important. All right. So because we want to trap those the oxygen molecules that are coming out of there, we want to put a special ingredient, which is just dish soap, something you can find at home.
Yep.
All right, are you ready?
Yep.
Because this is, I don't know if anyone knew or saw Camille's performance, but it went whoo, up. So let's see if that happens, okay? Okay.
Oh, it's not working.
Let's see, let me give it a swirl. Let's see if anything. Swirl, swirl, swirl. Okay, I mean, it's foaming. You see bubbles.
You can see the bubbles.
Yeah, so the oxygen is being released, but it's not that quick.
No.
It's not that fun. And we're not here for a very long time, so because I think by the end of this week, you'll probably be fine and see all the bubbles come out. But that's not that too fun. So are we missing something?
You might want to use a catalyst. It might help it go faster.
A catalyst. Okay, is that?
What's a catalyst?
So a catalyst is something that speeds up a chemical reaction. It doesn't really change how it works. It's basically like if you were biking up a mountain and instead of trying to pedal up the mountain, you used a motorbike. So it just helps you get there faster,
Or
but
an
you're doing the same
electric
thing.
scooter.
Right, exactly. So it'll just help it go faster. So that might be part of the problem.
Okay, so catalyst. So I got a brand new one over here because, you know, especially in science, you want to try again, right? We're not going to sit here and say, oh, it didn't work, let's just give up.
No.
Let's try it again. So I have a
happens all
brand
the
new
time.
one, and then I have our catalyst. It's potassium iodide, or Ki.
Okay, perfect.
So I think we should add some more soap.
Absolutely.
I'm going to squeeze a lot of soap in there, and
we
then
still need to trap the bubbles.
yeah, exactly. We still need the soap for the bubbles, and then do you want to add a fun color to it?
Yeah, what color do you want to do?
Melissa,
What color do you want to do?
Oh.
I'm going to squeeze a lot of soap. I'm just
What
going to empty this out.
Here you go.
Can we mix some and make purple?
Whoops.
We can.
Can we make purple?
Why not?
Yeah.
Let's do some
I'm going to give this a swirl really quick
red
before-
and some blue.
So there's a fun trick.
Do I put it
You
in
talked about stripes.
Yeah, we
Let's
can make
try some
stripes. If you just like to have the food coloring drip down the side. And you can do 2 different colors if you want to.
Oops.
No,
2
that's
different
okay.
stripes.
Yeah, I want to do
Yeah, absolutely try that.
blue.
All right.
I've never
enough?
tried stripes before.
I know, we're gonna see.
I'm excited to see. This is part of the experimentation for me to see how this ends up.
I feel like it might be like toothpaste colors. The balloon
Oh, that would look a lot like
And we're making
toothpaste.
elephant toothpaste, so there you go.
Perfect.
I'm just curious to see what the temperature of this liquid is.
Yeah.
Just curious, and we'll take a note.
What kind of reaction is this?
Okay, 67.1. Can you remember that?
Absolutely.
67.
67.1.
Yeah. What kind of reaction this is? So it's a chemical reaction, and what's happening is that the H2O2, what's happening is when we add our catalyst in there, it's actually going to break off, and it's going to be breaking bonds so that the O2s can release. So do you want to see it happen?
Yeah.
Yes.
Do you want to do the honors?
Okay, absolutely.
Okay, so do you want to just pour a lid on there and see what happens?
Yeah,
And
let's
then
start
let's
it.
talk about what we should do
Yeah.
once we pour it all the way in there.
This is very important.
Yeah, so I think once we pour it all in there, should we clear some of these stuff off
Yeah,
too?
we might want to.
Yeah, let's just put it behind us, yeah, in the corner. Perfect.
As far away from it as possible.
Yes. Ooh, I dropped one, that's fine.
Not to scare you.
I'm used to doing weather. It's not this messy.
And then we're just gonna take a step back and see what happens.
Yep.
Ready?
We're ready?
Okay, so
So we're going to do a little bit to start, and then we're going to give it a go. Are you ready?
Yeah.
See what starts to happen. Start to see a little bit more
Okay.
bubbles.
Keep pouring in.
Now we're going to do it. There she goes.
Woo!
That's cool.
Oh,
You can see
wow.
the little stripes.
And you can also see the steam coming off of it, right?
Absolutely. So I think maybe the temperature changed.
Yes, let's see. So what was the number before?
67.1.
This is now at 159.6.
Wow.
Oh, wouldn't want to touch that.
So that chemical reaction, right? All the bonds breaking and then reforming new ones to release the oxygens. That's the energy is being released in the form of heat. So that's what we see here. And we don't want to touch this because we don't. 160. We just said
Of
it.
course.
The number.
It's hot.
Too hot to touch, right? It
looks
smells really nice too.
It does. It smells like dish soap.
So Lahiri, this is one of the science experiments that are possible to do at Science on Stage. When you guys go in there and are doing these at schools, they're like assembly style. How long do they last, and like, what are the kids' reactions when they see stuff like that?
Yeah, so this is exactly why we do this, because it's a reaction of like, whoa, what did we just witness? And there's science like, behind it. Let's learn about it. And so this is actually what we end with, because it's kind of the big bang of all the different activities we do.
Timber!
There it goes.
And so, we have like a kind of like a menu of activities that the schools can pick from, and they get to tailor it to the ages and the different grades. So it's a lot of fun. We have our Science on Stage folks who have like a little bit of theater personalities coming out. So we're not just sitting there, talking at the children. We're talking with them, having them answer questions.
Still going.
Oh my
Still
gosh,
going.
that's still going.
It'll keep reacting until all of the hydrogen peroxide has been decomposed
Yeah.
inside that cylinder or the flask. So it will continue to go. It's going to keep on chugging.
Oh.
Do you know
Oh
why
my
it's
gosh.
called elephant's toothpaste is the real
No,
question?
no.
So do you see how it comes out of there like a tube of toothpaste?
Yeah.
But that's a little bit bigger than yours, right?
Oh,
And
that
do you know
makes
how
sense.
big an elephant's tooth is actually?
No.
It's like this big.
Oh.
So we can't use like a little tube of toothpaste for that, right?
But you can't brush an elephant's tooth with this. It would not be good.
Let's not do that.
Well, thank you so much for joining us here today and doing this little Science on Stage demo. I think at the end of the day, the story of this is science is cool. As women, as
Absolutely.
girls,
Of course.
you can be a scientist. You can wear a crown, you can wear
Yes, you
makeup, and you can study science as well.
Absolutely.